Okay, dear students, now we are moving ahead towards the stepping stone method. From the Vogel approximation method, we have found this solution. And with this solution, we are moving ahead toward the stepping stone method. Stepping stone method, stepping stone method. Okay. Stepping stone method. Stepping stone method. Stepping stone method. So what is stepping stone method? Stepping stone method is basically to find out whatever your allocations are. You see there are multiple allocations. They are optimal or not. First you need to see that whether the number of allocation is as per the requirement or not. If m plus n minus 1 equals to m is the number of rows, so 3, number of columns 4 minus 1, that is 6. So 6 must be the number of allocations. We must find out from the initial basic solution of the Vogel approximation method. So you see 1, 2, 3, 4, 5, 6. Alhamdulillah, we have found the 6 allocation. So you see now because of this we can move ahead towards the stepping stone method. Now in the stepping stone method, what our objective is to find the optimality. What does that mean? It means that for example 11 is the per unit cost when you transport the goods from the warehouse 2 to the customer 3. Okay, so it may not be optimal to send 50 units from the warehouse 2. It may be optimal to send less than 50, or this 10 would be feasible to send from other warehouse. So this is kind of optimality which we will achieve through the stepping stone method. So let's start with that. So first you need to do what you need to do. You need to find out the okay, dear fellows, you see what do we have for stepping stone method. This is the matrix we have, as we already discussed, got from the Vogel approximation method. Now we want to optimize this solution, that whether the allocated number of units to the particular cost are the optimum or not. Okay, let's find out. First we need to define these unallocated cells with the x1, x11. X11 is, this is the row, this is the row. Okay, these are the rows. So these rows 1, 2, 3. So because of the rows it is 1, because of the column it is 1, because of the row it is 1, because of the column it is 3. Okay, so this is x11 is for the cell 5, x13 is for the cell 20, x21 is for the cell 2, x22 is for the cell 8, x24 is for the 20, x32 is for the 16. 32 means third row and second column. Okay, let's move ahead. Now we have just represented these cells with the x rows and column numbers. Now let's move ahead. First, how do we go about it? We start the optimality through this unallocated cells, and remember what we need to care about it is we need to develop the loop. We need to develop the loop. We need to develop the loop. For example, you see this is the unallocated, first unallocated x11. So x11 cost has to be, x11 cost is plus 5, x plus 5. भाई मैं रिकॉर्डिंग कर रहा हूँ यार. Okay, now you see x11 is over here, so we have to write plus 5. Why plus 5? Because from wherever we start we have to mention the plus sign over here. Okay, so with every starting point you have to start with the plus. Then remember, you have to develop the loop. How can we develop the loop? With the proper rules. Rule is either you go to the horizontal side or the vertical side. Okay, so in the horizontal side, you see 0 is there. So if you would go with the horizontal side with the 0 as second one, so you see there is no vertical one. Yes, there is a horizontal one, but there is no vertical one. So the loop will be prolonged or it will be disturbed. So what we do, we do not go over here. Okay, we may go over here, the vertical side. Vertical side is 0, 30. So if you go to 0, 30, 0, 0, so you see that there is a possibility of going to the horizontal to 14 and 18. So we will not go to the 14. Why? Because there is no possibility of going back to the 5 from the 14. How come? Like 14 is, there is no vertical loop being made from the 14. You see, so you see there is no chances of the vertical loop. So we cannot choose the 14. So we will choose the 18 instead. So when we'll choose 18, there is a chance of going to the 10. And when we reach to the 10, we can directly reach over here, 5. We will skip 0. Why? Because we always need to remember. Okay, dear folks, this is the solution of the stepping stone method. This was the matrix we found with the Vogel approximation method. And what we have done, we have made it to the, we just checked it, verified it, whether it is optimal or not. And how we have found it? We have found it through this, because what we have found all the positive cost of the unallocated cells. For example, how we did for the 5, what we did for the 5, we started from here and we had a choice of going to here, either going to 0, this 0, or going to this 0, or going to this 10. We have a choice. So we need to choose the one which can help us in making the loop. So you see 10 is helping us in making the loop. Loop is going in this manner or this manner. Okay. So starting from here with the 5, 10 is the best option. And when we go to the 10, 18 is the best option. When we go to the 18, the 0 is the best option. So you see this is over here, plus 5. You may also go this way, plus 5 minus 0, plus 18 minus 10. So that equals to plus 13. Okay, so plus 13 tells us that there is no need to further allocation in this particular cell. Okay, so it is optimal. So when we move ahead, x13 is the 20. So starting from the 20, for the 20, what we need to do for the 20, we start from the 20 plus 20. Now we have a choice to go to the horizontal way or to the vertical way. If we go to the horizontal way, we have a choice to go 0 or 10. So 0, if we go to 0, can we make the loop? No. If we go to 10, can we make the loop? Yes. Okay. So this will be the best choice, that plus 20 minus 10 plus 18 minus 14, and you see the loop is going on. We will ignore 11. Why? Because as I already mentioned, that we need to be in even, and we try to make it in the minimum 4 way. In the minimum 4 way, that is the minimum, with the minimum 4, we make a loop. So you see 20, 10, 18, 14 are the minimum. 20, 14, 18, 10 are the minimum. Next, we move ahead to the x21. For the x21, you see plus 2. For the plus 2, we have a choice of 5 or 0. So 5 is unallocated, 0 is allocated. Yes, we may go over here. So 0 is allocated. So is it helping us in making the loop? You see 14, 11. Yes, it is helping us. 14. We are not going towards 18. You see Why? Because 14 is the shortest one. 0, 14, 11, 2. 2 plus 2 plus 2 minus 11 plus 14 minus 0 plus 2 minus 11 plus 14 minus 0. And the answer is plus 5. The answer is plus 5. The answer is showing that this is unallocated and there is no problem with the idea. It is optimum. X22, that is the plus 8. So let's find out the cost. So you see, if we go with the 8, so with the 8 we have a choice going to 0. Either we may go to 0 or to 16. We cannot go to 16. Why? Because unallocated. We can go to 0 because it is allocated. So okay, and we can go to 11. We cannot go to 2 because 11 is allocated. Okay, we cannot go 20, which is unallocated. Okay, so we have a choice of 11 and 0. So you see, it's a tricky part. Why? Because there is no loop as such directly we can get from the 4. Dear students, you see, when we talk about the x21, x22 is 8. So you see, 8 is the x22, the second row and the second column. So what you see, we need to find the allocated cells to make a loop. Either we can find in the horizontal manner or in the vertical manner. So let's see what is near to us, which is making the loop. So start with the 11. 11 is the horizontal, first horizontal we have, shortest one, starting with that. From 11, where we can move to 14, yes. From 14 where we can move to 18 or 0. So 18 would make a long loop, and 14 will also make a long loop. So let's see how we will go about it. So we can also go, see, through this we can find that this 8 requires at least 6 cells to make a loop. Why? Because there is no direct loop over here. You see 0, no loop as such. There is a break over here. You see break over here. So we have to go in the indirect manner. Let's see. Let's finalize it. Start from the 8 to 0, then 10, okay, then 18, then 40, then 11. So first we'll go to 0, plus 8 minus 0, plus 10 minus 18, plus 14 minus 11. That is a loop. So you see, this one is the tricky one. It is not making a easy loop. It is going to with a big loop, but it must be in even. So you see, plus 8 minus 0 plus 10 minus 18 plus 14 minus 11. 1, 2, 3, 4, 5, 6. 6 are there. So they are in even. Good to go. So when we calculate plus 8 plus 10, 18 minus 18, 0 plus 14 minus 11 plus 3 is remaining. So plus 3 is remaining. So plus 3 is the positive one. So it is, we are fine with this because it is optimal. We do not need any more allocation over here. So x24, let's find the another unallocated one, that is the 21. So plus 20, we will start from the plus 20, and from the plus 20 we will move ahead. We have a choice to move ahead to plus 10 or plus 18 or plus 11. We have a different choices. In fact we have many choices, and all are very close. So if we want to make the closer loop, we have multiple choices. So but we cannot choose the 10 because the loop is not forming. So if we take the plus 20 over here and plus 18 plus 14 plus 11, so that would be the good one. Plus 20 minus 11 plus 14 minus 18. So this is the best loop. So the answer would be plus 5. Plus 20 plus minus 11 plus 9 plus 14 plus 23 minus 18 plus 5. Plus 5. Whenever we get the plus, it means there is no need for further optimality. X32 is the last one, 16. So for the 16, we need to see whether the loop is the closed loop or the long loop. So for the closed loop, we try to find in the horizontal manner 14 and 0 is there. So with the 0 there is no loop as such. With the 14 there is no loop as well. So we will cross 14 and we will go to 18. From 16 we will go to 18, and from 18 we will see in the vertical manner, do we have a choice? Yes, we have a choice of 10. Oh dear folks, you see the X22 is 8 is pretty tricky one. Why? Because you see there is no direct loop, there is no shortest loop we have. If there would be an allocated over here, quantity over here, that will be the shortest one, but it did not happen. So we have to go with the long loop. Long loop may be of 6 or more than that, but it must be an even number. So let's begin with that. We may go to 0, okay, in the vertical, or we may go to the horizontal way. So it can be this way or that way. I am going to the vertical way. So you go to the 0, and from 0 you see you have a choice of 10 to move ahead to make a loop, and from 10 you have a choice to reach to 18, since there is no allocation to you reach to the 18, and from 18 you see you have a choice of going to 14 or 0. 14 is a better one because it is closer to the 8, so that we can easily move back to 8. 14, and the closest loop, closest cell to which is allocated is 11. So from 14 we'll move to 11 and we will reach to the 8 again. So you see from 8 plus 8 minus 0 plus 10 minus 18 plus 14 minus 11. So that will be over here, and you see over here plus 18 minus 18 0, and plus 14 minus 11 is plus 3. So plus 3 is the cost you see over here. And over here you see we are done with the X22. Now we are here to X24, that is 20. For the 20 you see, we have to see that which is the shortest loop. So over here not many, but there is a very close loop over here. We can go to 18 in the vertical manner, we can go to the 18, and we can go to the 10 as well. Okay, you have a choice, or you can go to the 11 as well. So if we go to the 10 there is no loop as such, so we will go to the 8, we may go to the 18, and we may go to the 11 as well. The both manner you make a loop because 14 is there. So I've gone to plus 20 minus 11, okay, plus 14 minus 18. And if you do like this, then plus 20 minus 11 plus 9 plus 14 is plus 23 minus 18 is plus 5. So plus 5 is also positive. Positive means that the allocation is optimal, there is no problem with the idea. Now the last one is the plus 16. Plus 16 is the X32. X32 we will start to find the shortest loop. So shortest loop is when we go to the horizontal. 0 is one of the way, but there is no loop being made. When we go to 14 there is no loop being made. So we will go to the 18. Yes, there is a loop being made. 16 plus 16 minus 18 plus 10 and minus 0. So this is the loop. You see plus 16 minus 18 plus 10 minus 0. So plus 16 minus 18 minus 2 plus 10, that will be plus 8. So we have got all the positive value. What does that show? It shows that our Vogel approximation method, which gave us these allocations, are optimal. And the cost we have found from this Vogel approximation is 0 into 40, 10 into 10, 11 into 50, and 0 into 30, 14 into 10, and 18 into 60 is the least cost. So it is the optimal cost. So you see, for supplying the 200 quantity, 40 plus 10, 50, 50